So let's actually apply a binomial distribution formula to one of these problems. Each child of a particular set of parents has a 25% chance of having type O blood. Suppose the parents have 5 children. Find the probability that exactly 2 of the children have type O blood. So first of all, this is a classic example of a binomial distribution. We've met the condition of bins. It's binomial because either a child has type O blood or they don't. Each child is independent of each other, whether or not they have the gene to have type O blood. N stands for a fixed number of trials. Well, we have 5 children. And S is we have the same probability. Each child has the same chance of having type O blood. So the formula is as follows. Or it could also be written as follows. And I tend to use the second way. So let's look at the information we're going to fill in. We have 5 children. That's the total number of trials. We want to see if we have exactly 2 children with type O blood. The chance that a person or child has type O blood is 25%, and Q is 1 minus P, so it's 1 minus 0.25 or 0.75. Let's fill into the formula. And 0.75. And right away I normally simplify this. Let's take out our handy dandy calculator, and we're going to quickly enter this in. So you would go into combinations, and it would be 5, comma, whoop, I have a bunch of too many commas. And then parentheses. For the next video, I'll show you some shortcuts, but not for this one. And 5 minus 2 was 3. And you would hit enter, and we can actually express this one as a fraction by hitting menu, number, and let's hit approximate to a fraction. Whoop, I think I missed that. Let's try it again. Menu, number, approximate to a fraction. So menu, number, approximate to a fraction, and hit enter. And you see that the final answer is 135 over 512. So why don't you put the video on hold, and what I'd like you to do is make sure that everything is in your notes, and I am going to go on to the next question in a second. So for the second part of this question, they said find the probability that at least 4 of the children have type O blood. So it's similar, but it's not quite the same. At least means that number or higher to the maximum number of trials, just like I would like you to get an A, so I want you to get at least a 90 on your next test. So you're going to count up. So we want greater than or equal to 4. And when you have an at least, or like the next problem, at most, it's the same process except you're going to do it multiple times. So N is still 5. That's the total number of trials. K in this case is 4 to 5 because 5 is the maximum you can go for. P is 0.25 and Q is 1 minus P or 0.75. And we're going to fill it into the formula. So the probability, you're just going to add this together. X is equal to 4 plus the probability, not X. Yes, it is X. X is equal to 5. And so now we're going to fill in the formula. So it's going to be 5C4, 0.25, that's your P raised to the 4th, 0.75, that's your Q, 5 minus 4, which we know in this case is 1, plus, it's going to be 5C, K is now 5, 0.25 to the 5th, and 0.75 to the 0. And you would then substitute again into the calculator like I showed you before. Remember, I'll show you a trick in the next video. And when you add those two pieces together, you get 15 over 1,024, plus this one turns out to be 1 over 1,024. Combine them together, and you don't need to reduce. So put the video on hold and record the information and make sure you understand all pieces of it before you move on to the next part. For part C, we want to find the probability that at most one of the children have type O blood. And so in order to do that, it's a similar scenario, but at most means something else. It means that is the maximum number K could be. It could also be less. Well, what could it go down to in this case? 0. That's always going to be the lowest number. So in this case, we're looking at the probability K is less than or equal to 1. So N is 5. K can either be 0 or 1. P is equal to 0.25. Q is, as before, 1 minus 0.25 or 0.75. And we're going to add those two pieces. We're going to substitute into the formula. And we're going to simplify this. And again, in the next video, I'm going to show you a really nifty trick. But for this particular video, I'm just going to write down the numbers that I calculated before. You should check my arithmetic. Again, you do not need to reduce the final answer. Okay, I hope this helps.